Hello friends, today we will be demonstrating an experiment to create a foul food detector. Now the basic idea of this is to measure the capacitance change when we place a fruit between the plates of the capacitor. The symbol of the capacitance can be given as shown, where D represents the distance between the parallel plates and the plate area is given as length into breadth. Now capacitance of a capacitor with specified dimension is given by the formula A into epsilon by D, where epsilon represents the dielectric constant. It is the dielectric constant of the material which is placed between the plates, parallel plate capacitor. Now what we have done, we have placed the fruit between the parallel plate capacitor, and since when it starts rotting, it releases ethylene gas, and the dielectric of the ethylene gas is greater than that of the air. So the capacitance increases. Now let us look at the hardware used in the experiment. Firstly, we are using a function generator which acts as an AC input voltage source. Then we have a breadboard which establishes all the connections. Then we have four 2.7 picofarad capacitors. Then there is a multimeter to which we are measuring the value, and lastly we have made a capacitor. Its dimensions are 25 cm length, 10 cm breadth and 6.5 cm width. The plates of the capacitor are of aluminium and it is a parallel plate capacitor. The components which we showed you earlier have to be connected like this. First of all, we will be giving you an AC input of 3.9 kHz via function generator. The aluminum plate capacitor and the four capacitors of 2.7 picofarads are connected in series. Then we have given an input source voltage, as you can see. The four capacitors which I mentioned earlier are connected parallel to each other, each of which are of 2.7 picofarad. Total they give us a 10.8 picofarad. After the connections are made on the breadboard, now let us see what change is observed across the capacitor in its capacitance after we place the foul fruit between the plates. First, we see what is the capacitance when air is the dielectric. The capacitance of the capacitor is measured as 0.137 nanofarad. Now, we place a fresh apple between the parallel plate capacitor and the capacitance slightly increases to 0.138 nanofarad. Now we see that the change is not that much because the apple we took is fresh apple. It is not releasing any ethylene gas. Next, we put an apple which has started ripening, and this apple which we have put has a value of around 0.191 nanofarad, where we see that the change is very drastic. So what we have observed is that the apple has started ripening and it is releasing ethylene. Next we put some slices of apple which is on the verge, which has already dried up, and it is on the verge of dying. The capacitance which we have seen is 0.137 nanofarad, which is slightly different from the one which we have measured with air and the fresh apple. Why? Because since the apple has dried up, it has already released its ethylene gas. So the dielectric of this apple is very low. The application of this detector is as a sensor in home refrigerator. It can also be used in grocery shops and also in food storage units. We can measure the input difference. It can be manipulated accordingly via microcontroller or an op-amp and sometimes even an A to D converter. As you can see, this is our foul fruit detector. It can be automized to be used in industry.